So this video is for Integrated 3, Chapter 4, D-Day number 3. The first problem is dealing with a normal curve. And for this normal curve, we have a mean of 75. I'm just going to turn my paper here for a sec. Okay, so I can just write it a little neater. Okay, so we have on this one a mean of 750. We have a standard deviation of 50, so that means this would be 800, this would be 850, this would be 900. I'm just adding 50. Going the other direction, I'd have a 700, a 650, and a 600. Let me flip it back. Okay, so for this, my mean is always in the center at the highest point, okay, above the highest point. This is actually one standard deviation, z-score. This is 2, this is 3, okay? This is -1 as a z-score, -2, and this is -3. That's how many standard deviations you are off of the mean. Positive means we are above the mean by that many deviations. Negative means we're below the mean by that many deviations. Now, they're asking us for what percent of the iPhones are more than 800. So we want this area here is what we're looking for, okay? We're trying to find the percent. So we're going to do, I'm going to move this over. If we're doing it on our calculator, we're going to do normal CDF. And we're going to put in the lower bound, which is 800. The upper bound, which is infinity, positive infinity, we're going to type it in as 10 to the 99. Our mean is 750, and our standard deviation is 50. And so I'm going to put that into my calculator. And I'm going to end up getting a 0.1587. So this area here is going to be 15.87%. Now, some of us I know are using the tables. And so if I'm going to use the tables, I need to find the z-score. Now, the z-score here happens to be 1 because it was an actual nice standard deviation. So I'm going to go to my table, the one that's going to start from the center out, and I am going to look for 1. So I'm going to stay in the first column, and 1 is right here, 0.3413. Okay, so this right here is 0.3413. We want the rest of it. So the area under a normal curve is 1. Can understand a normal curve is 1. And so that means it's 0.5 on each side. So if I'm using the table, I would take 0.5. I'm going to subtract 0.3413. And when I take 0.5, 0.5 minus 0.3413, I end up getting the same 0.1587. So that's how I would do it if I was using the table. On number 2, another normal distribution. This one we have a mean of 78 and a standard deviation of 2. We want to figure out what the score needs to be for him to be in the 85th percentile. So this is 0.5, this is 0.5, okay? So if we want, let me get that back. If we want, to have, let me just move that and move it back. If we want to have be in the 85th percentile, that means we have 85% of the students are scoring under him. So, all right, one more time, sorry. Okay. So let's say that this is going to be 85%. percentile. Okay, so we want an area of 0.85. I want this area right here to be 0.85. Okay, be 85%. And I'm trying to find the score. That score should be higher than 78. So this time I'm going to do inverse norm because I know my area. Okay, so I want my percent to be 85%. So I put 0.85. Then I put my mean. Then I put my standard deviation, which is 2. And when I put that into my calculator, I end up getting an 80.07. So that's what he would need to score in order to be in the 85th percentile. Now, if we're doing this with the table, I'm going to look for this 0.85 on the table, but I'm looking for it in the columns. And I'm going to use the second one, okay, because that's starting from the left all the way to the other side of the mean. Okay, so I'm looking for a 0.85. So let me just move this. Okay, so I'm looking for 0.85. So it looks like, as I'm going across, it's in between 1.03 and 1.04. Okay, so I think this one's going to be closer to what I want. And again, that's going to be a 1.04. 1.04. That is my standard deviation. Okay. That is my Z score, 1.04. So how do I make this become a score? So I know that the mean is 78. I know every time I go out one standard deviation, it's 2 points. So I'm going to add 2 every standard deviation. And his standard deviation is 1.04. I'm going to put that into my calculator. 78 plus 2 times 1.04. And I get an 80.08. So you see in both cases, it's about an 80. On number 3, the time to finish a test is normally distributed and has an average mean of 40 minutes. So this is 40 minutes with a standard deviation of, it looks like 1.8 minutes is what it looks like. It is 1.8 minutes. And we want to know what percent of students will finish before 20 minutes. Okay. So 20 minutes would be on this side. And I want the area here because that would be my percent. So I am going to do normal CDF. My lower bound is negative infinity, which is going to be negative 10 to the 99. My upper bound is 20. My mean is 40, and my standard deviation is 1.8 minutes. When I put that into my calculator, I end up getting out 0. Now, if that is a 1.8 standard deviation, it makes sense because if I had gone out 3 standard deviations, okay, 40 minus 1.8 3 times 40 minus 1.8 times 3. Try it again. I would have ended up with a 34.6. So that would be 3 deviations in front of the mean. Okay, when I go out 3 deviations, okay, now I didn't draw this really to scale here, but when I go out 3 deviations, what happens is in both directions, I should be at 99.7% of it. So 20 is way far out. That would be like a huge outlier. So 0% of the students should be scoring there. If I'm doing it with my table, okay, I would find the Z score for this. So I'm going to take 20 minus 40, divide it by 1.8. and 20 minus 40 divided by 1.8, I get a negative 11.11. And that is not going to be found on my table because our tables go up to about a 3. Okay, sometimes you'll see ones that go a little beyond 3, but they're not going to go out 11 standard deviations. So the probability of that is 0. Okay, on number 4. On number 4, okay, a relative frequency table. And we want the for the 5K times that are here, bin with a 5 and minimum time of 14. So this is going to be 14. I am adding 5. So that's going to be 19. I add 5. That's going to be a 24. I add 5. That's a 29. I add 5. And I think at this point, I'm already to where I've already have all the data. So my intervals are going to basically be from 14 to 19, from 19 to 24, from 24 to 29. Now, how many items are from 14 to 19? Well, let's see. I've got 1, 2, 3. I'm not going to include the 19. So that's 3 out of 10, which is 0.3, because that relative frequency means I need to change it to a percent. What percent of the data? Now, the next one is from 19 to 24. So 1, 2, 3, 4, 5. That's going to be 5 out of 10, which is 0.5. The 24 is not going to be counted until the next interval. So 24, 24, 2 out of 10, or 0.2. So when I'm graphing this, I am going to go 0.1, 0.2, 0.3, 0.4. Let's say this is 0.5. I'm going by 0.1s. So if I'm going from 14 to 19, I'm going to go up to 0.3. From 19 to 24, I'm going to go up to 0.5. And from 24 to 29, I'm going to go up to 0.2. And there's my relative frequency distribution. On number 5. So on this one, this is dealing with linear programming. We are really just trying to write some inequalities. That's what constraints are that they're asking for here. So Latifa has an online shop where she sells clothing. It takes 4 hours to make a pair of jeans and 1 hour to make a sweater. And she has 30 hours to make the clothing. In addition, it takes 2 square meters of cotton to make a sweater, 5 square meters of cotton to make jeans, and she only has 450 square meters to use each week. She makes a profit of $40 on each pair of jeans and $60 on each sweater. Now, that would be our objective function. Profit equals, I am going to have X be the number of sweaters. I am going to have Y be the number of jeans. So Y equals number of jeans. Okay, so my objective function is always when I'm trying to maximize or minimize. So I'm going to maximize profit, and I get $40 for each sweater X, plus $60 for each, sorry, let me rearrange this. I'm going to change the order because the order they have it in is jeans first. So let me put jeans first. It doesn't matter, and then I'll put sweater second. That way I kind of keep the pattern. Okay, so start again. It's $40 for each pair of jeans, and we have X pairs of jeans. It is $60 for each sweater, and we have Y sweaters. That's your objective function. Now, the constraints are going to be restrictions on different resources. So one of them is going to be on hours. I'm going to write an inequality on hours. We only have 400, let's see, what is it? 30 hours a week. So I'm going to have less than or equal to 30. It's 2 hours for each pair of jeans, so 2 times X. It's 1 hour for each sweater, so plus 1 Y. That is going to be one constraint. Then I'm going to have another constraint on cotton. Oops, sorry. On cotton. Yeah, the other constraint is on cotton. So for cotton, we have 450 square meters, and it takes 2 meters of square meters of cotton to make a sweater, and 5 square meters of cotton to make jeans. So 5X, that's for your jeans, and 2Y, that's for your sweaters. We want to make sure we don't mix up the order because they actually switched it here on this part. And that's it. That's all you need to do. They're not asking us to graph it or find any answers. Now, 6 is review. These are the let u equal. So we have a 2x plus 1 underneath the square root in both of these. So I'm going to let u equal the square root of 2x plus 1. And so I'm going to rewrite this as 4u squared plus 5u minus 6 equals 0. And I'm going to do a box to diamond to factor this. So when I'm doing that, I am going to put in my first box here 4u squared. Let me zoom in a little. 4u squared. And my negative 6. Those multiply to a negative 24u squared, but they also have to add to that 5u. So that's going to be an 8u minus 3u. It doesn't matter which one I put where. Once I do it, my outside is going to be set. So when I'm doing this, I focus on my 4u squared. And so when I'm focusing on that, it could be a 2 and a 2, but because of this 3, I know it can't be a 2 and a 2. So it's going to be a 4 and a 1. So 4u and u. 4u times what gets us 8u? 2. U times what gets me a negative 3u? Negative 3u. So my factors are going to be a 4u minus 3 and a u plus 2. We're going to set that equal to 0 and solve. And so one answer is u is equal to 3/4. Another answer is u is equal to negative 2. So I am going to take the square root of x plus 1, which is what u stands for, set it equal to 3/4. I'm also going to take the square root of 2x plus 1 and set it equal to a negative 2. Now, when I set it equal to a negative 2, a principal root cannot be equal to a negative, so this one I'm just going to stop. It's not going to be part of my answer. So for the other one, I am going to square both sides, and when I square both sides, I am going to get a 2x plus 1 is equal to 9/16. I'm going to minus 1 from both sides. So I'm going to have a 2x plus 1. I mean, sorry, 2x equals. And when I subtract 1 from 9/16, I get a negative 7/16. I'm going to divide by 2. And when I divide by 2, I really can times by a half. I'm going to get a negative 7/32 as my answer. On number 7, okay, so these ones we're going to be sketching. I'm going to pause and just add graphs on so I can be accurate so people can see how to accurately graph these. Okay, so they did just ask for sketch, but I'm going to show how to accurately graph these. So on this one, my inflection point, because this is a x cubed problem, a cubic problem, is a -2, -1. So I'm going to go to -2, -1. That's my inflection point. I'm going to keep that in a different color just so we know where I'm doing this from. I have a negative in front of this. So what I'm going to do is I'm going to come to this red point. I'm going to move out 1. I'm going to cube 1, which I would normally go up 1, but because of the negative, I'm going to go down 1. I'm going to come out 2. 2 cubed is 8. I'm going to times that by a negative, so I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to approximate. Now going the other direction, -1. When I cube a -1, I get -1, but I'm timesing it by a negative, it makes it a +1. When I go out 2, I get -2 cubed, which is a -8, but I'm timesing it by my negative, so I get a +8. So 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to connect these. And there's my graph. Now on the next one, it is a square root graph. 5, 0 is my starting point. So 1, 2, 3, 4, 5, 0. As I go over 1, the square root of 1 is 1. If I went out 1, 2, 3, 4, the square root of 4 would be 1, 2, and so forth. Now, when we graph this, it's going to start at this point, and then it's going to go forever like that. On letter C, let me move it so I get both of these in here. Okay, so on letter C, this, if we think of a locator point for this, would be in -2, 3. So if I went to -2, 1, 2, 3, that point is going to be important. It's going to be where my asymptote is going to go. So I am going to have a horizontal asymptote. Okay, a horizontal asymptote at y equal 3. Okay. And then this point that I have here, it's not a point on our graph. That's going to be like our starting. Okay, that's where I'm going to start my graph. And I'm basically going to be at this point graphing 4 to the power x. So if I start here, 4 to the power 0 is 1. If I move over 1, 4 to the power 1 is 1, 2, 3, 4. As I go over 2, 4 squared, 16. It's going to get a little too big for me to graph a lot of it. Let me just put these points. I'll put them in kind of a black so you can see those points. The next one is going to have 2 asymptotes. It's going to have a horizontal and it's going to have a vertical. Whatever makes our denominator 0, okay, which is a 1, x equal 1 is going to have a vertical asymptote. And the +2 here, that's going to give us a horizontal asymptote. So this one is at y equal 2. This one is at x equal 1. Now, I have a negative, okay, which means instead of it being like here and here, didn't mean to take off the graph, forgot it. I had added the graph. It's going to be here and here. That's what's going to happen. Now, I am going to think of this as like a -1 on top. So as I come to like my center here and I go over 1 times what gets me a -1? -1. 2 times what gets me a -1? -1/2. 3 times what gets me a -1? -1/3, and so forth. So what's going to happen is this is going to go like this. And then if I come here and go -1, -1 times what gets me a -1? A +1. and so forth. And so we're going to get the graph here. Okay, and this is kind of the one point I want you to be accurate with, and this point here. On number 8, solving a system. Okay, so we have to find an x and a y. Okay. I'm going to do equal values. So I'm going to go square root of x plus 6 is equal to x plus 4. I have a square root graph and a line graph. This is where I want to check my answers to make sure I get a non-negative. Okay. I'm going to square both sides. So I'm going to get an x plus 6. When I square, let me just write it. When I square x plus 4 squared, it is a perfect square trinomial. I get an x squared plus 8x plus 16. If you need to do x plus 4 times x plus 4, do it. I want to get 0 on this side. So it's going to be an x squared plus 7x plus 10. I'm going to factor that, which is really saying what multiplies to 10 and adds to 7 in this case. So that's going to be a 2 and a 5. So I'm going to get x equal -2, and I'm going to get x equal -5. Now remember, I need to check these into this. So when I put a -2 in here, I end up getting out a 2. So that's acceptable. When I put a -5 in here, that's going to be a problem because that's going to make that negative. So this one's not going to be a point. So I'm going to have 1 point. It's going to be -2 comma. And again, when I put -2 in here, I end up with a +2, and that is my point of intersection. On number 9. On number 9, we're going to factor. We always want to factor out the greatest common factor first. So number-wise, I'm going to factor 4. X-wise, I'm going to factor an x cubed. And then I'm going to be left with 1 minus 6, x to the 4th. Okay. So now when I'm looking at this, I want to see if I can factor this further. The 6 is making this not be a difference of 2 squares. The 4 here could have been a difference of 2 squares, but that 6 is fouling us up. That's going to be our final answer. Sometimes when you factor out what you can, that's all you can do. Now on B, I'm going to factor out a 3 and an x squared. And when I do, I'm going to get a 6x squared minus 7x, because it was a 21, minus 3. For this one, I believe this time we can factor this further. So let's see. I'm going to do a box to diamond. I'm going to have my 6x squared, my -3, which gives me a -18x squared, but it has to add to that -7x. I'm thinking -9x and a +2x. So -9x, +2x. So then I'm going to focus on my 6x squared right here. When I'm doing that, it could have been a 6 and a 1, could be a 2 and a 3. But with the 2 and 9, it definitely cannot have a 6 in either spot. So I'm going to have a 3x help with the 9, a 2x help with the 2x. 3x times a -3, 2x times a +1. Now, don't forget that in front of this, you had a 3x squared that was factored out. We still need that. And then we have a 3x plus 1. Let me write my plus better. I've been writing sloppy pluses lately. And a 2x minus 3. On number 10, they're asking us for domain. Now, remember, square root graphs are ones that start, and if it's a positive in front, okay, there's no negative, it's going to be going to the right as long as my x is a positive x, okay? So this would be like a positive square root. This one here, if I did it in blue, would have been a negative in front of my square root. This one that I'm going to do in purple, this one would have been where I have a square root of a negative x. And the one I'm going to do in green, this one would have been where I have a negative in front of the square root of a negative x. That's kind of what's happening with all of these. So this one's going to be like my red one. So it's going to be starting at some point, whatever makes this 0. So that's going to be, when I set that equal to 0, my x is going to be a 2/5. So let me just put it down here a little bit more. It's going to be starting at 2/5, comma 0, because there's nothing outside adding or subtracting. So what does that mean? Nothing to the left of this graph will have any x's will have value. So my domain is going to start at 2/5 and then go to infinity. Or x is greater than or equal to 2/5. That's another way of thinking about it. On 11, we're going to be doing a system of inequalities. Okay, so I'll do one in red, one in blue. So I'll do this one in red. This is an absolute value. It's going to be a -2, -1. So I'm going to go to -2, -1. I'm going to accurately draw my graph, which is basically up 1 over 1, up 1 over 1. Same on the other side. Pay attention to solid or dashed. It's solid because of the equal. So I'm going to draw my solid line. And then this is saying that I am shading wanting y's greater than or equal to. So if I come to my vertex and come up, this where I just put the dot, okay, that is where I'm going to be shading. I'm going to be shading this section. So I'm going to be shading everything basically inside of this absolute value. That's everything that was above that absolute value graph. Now the second one, vertex is going to be at 2, -4. So I'm going to go to 2, -1, 2, 3, 4. It's also going to be a solid line, okay, or curve, because it is a parabola. And for this, it's just a basic parabola. So to the right, 1 squared is 1, in either both directions, really. Going out 2 from my vertex, 1, 2, 2 squared is 1, 2, 3, 4. Going out 3, 3 squared is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and same on the other side. And this is going to be a solid curve. This one I also want to be greater than or equal to. So I'm going to shade everything basically inside of this parabola. And as I'm doing it, you see that there's a section that kind of is a purple tint now that both graphs were at. Okay, so right here, this section is where my answer is. Not where it's blue, not where it's red, but where it's purple. On number 12A, absolute value. So this is where some of us are having trouble. Do not write your two equations until your absolute value is isolated. So I am first going to, let me just write it here. I am first going to subtract the 2. So I'm going to have a 9x minus 15. Then I'm going to divide by the 3. Don't distribute the 3 in. So that's going to give me a 3x minus 5. I'm dividing everything on both sides. So now this is where I'm going to check my answers, because absolute values have to equal either 0 or a positive, cannot be a negative. So I'm going to write my two equations. I'm going to write one in blue. That's going to be the x minus 5, where I'm just going to take what is on the other side, which is a 3x minus 5. I'll do the other one in green, and that's where I'm going to take the x minus 5, that's inside the absolute value, and that could have equaled the opposite. So the opposite is going to be a negative 3x and a positive 5. You're making both terms that I circled that are on the other side of the equal opposite for your second one. Okay, and I'm going to solve. So I'm going to have a negative 5 is equal to 2x minus 5. I'm going to add 5. I get a 0. I get x is equal to 0 as a possible solution. My other one, I'm going to add 3x. Then I'm going to add 5. And I get x is equal to 10 over 4, or 2.5 if I want it as a decimal. Now, I'm checking my answers to make sure that they do not make this 3x minus 5 a negative. 0 will, so that's not going to be an answer. 2.5 is not going to make it negative. It's going to make it a positive. So this 10/4, 5 halves, or 2.5 is my answer. Now on B, we want to get both sides to have the same base. Now, normally what we do is if this is a 4, we usually try to make this into a 4 to a power. But 4 squared is 16. 4 cubed is 64. So that's not going to work. So I need to make both of them into the same base. So I'm going to make both of them 2 to powers. Now my 4 is going to be a 2 squared, and that's raised to the x plus 6. My 32 is a 2 to the 5th. Now, when I have power to powers, like I do over here, they're going to multiply. So this is going to become 2 to the 2x plus 12. 2x plus 12. And the other side is a 2 to the 5th. So when my bases are the same and they're equal to each other, then the exponents have to be equal. So 2x plus 12 has to equal 5. So 2x is equal to a negative 7. X is equal to a negative 7 halves. And that's our answer. On D. So on D, this is an inequality. Okay. So first thing I'm going to do is I'm going to get 0 on the other side. So I'm going to minus 29, which gives me a negative 32. Now, I'm going to find my boundary points. When I'm doing that, I'm really kind of thinking of it as an equal. When I'm finding my boundary points, I want to figure out what makes it equal. And so when I factor this, that's going to be an x minus 8 and an x plus 4. So that means x equal 8 and x equal negative 4 are boundary points. So if I take my graph, I put my negative 4, I put my 8, I look back at the inequality, it is strictly less than, which means I am going to have open circle at negative 4, open circle at 8. Because that makes it equal. I don't want it equal, I want it less than. The way I think about these is this is really a parabola. Okay, this x squared minus 4x minus 32 is a parabola. I want, where's the parabola? Less than 0. So that really means where is it lower than the x-axis. So I'm going to think of this as a positive parabola. Opens up. So as I'm going here, okay, this over here, let me just jot this. I am above right here. This is also above over here. And over here, in between these, I am below. And I want where the parabola is below. So I'm going to shade everything in between -4 and 8 because all of those x's would have given me outputs that are less than 0. We have to write out our answer, -4 less than x less than 8. The next one, I would isolate my absolute value. It already is. So I'm going to write my two equations. I'm going to think of it as an equal. Okay, so I'm really going to be doing this. Absolute value of 2x minus 3 equals 17 because I'm trying to find my boundary points. Boundary points are where it makes it equal. So I'm going to write my two equations. 2x minus 3 is equal to 17. I'll do the other one in red. 2x minus 3 is equal to a -17. And then I'm going to solve. I'm going to add 3. So I get 2x is equal to 20. Divide by 2. So I get x is equal to 10. The other one, I'm going to add 3 and I get a -14. I'm going to divide by 2 and I get a -7. So these are my boundary points. So I'm going to draw my number line. I'm going to have a -7 and a 10. I look back at the inequality. It is strictly less than or equal to. So since it's equal to, I am going to have a solid dot here at -7 and at 10 because I do want where it's equal. But then I also want where it is less than. So this, like a parabola, okay, I'm going to draw it in. Here I am above until I hit -7. Now I am below until I hit the 10, and then I am above again. So I want where it's below. And again, that's going to be everything in between -7 and 10. All x's in between are going to have outputs that are less than in this case, 17, because that line is at 17. So I'm going to have -7 less than x less than 10. Now, 13. 13 is completing the square. Okay. We're going to complete the square twice. So I'm going to get my x's together. So I'm going to have an x squared plus 6x. I'm going to leave some space. My y's, I have a y squared minus 12y. I'm going to leave some space. I'm going to take my 10 over by subtracting 10. And now I want to complete the square. So for the first one, I'm going to take my 6. I'm just going to jot it over here. Take half of my 6, which is 3. And then I'm going to square my 3, which gives me 9. That's what I'm going to add here and also to the other side. In red over here, I'm going to take my -12. I'm going to divide it by 2, which is a -6. I'm going to square a -6, which is a 36. So I'm going to add 36. I'm going to add 36. So now this is going to be x plus 3 squared. The other one's going to be y minus 6 squared. And when I do that math, -10 and 9 give me a -1 plus 36 is a 35. And that's our circle. Now, the last one, x and y intercepts. Now, when I am on a graph, okay, just a visual here, and I'm on the x-axis, this is 1, 0, 2, 0, 3, 0, 4, 0. Every single value, every single point on the x-axis, the y is 0. And that's why this line is literally y equals 0, because everywhere on that line, y is 0. Now, if I am here, let's say 0, 1 and 0, 2 and 0, 3, everything on this line, my x's are 0, okay? Because that line is x equals 0. So basically, I'm going to put 0 in for X and 0 in for Y. Okay, now if I'm trying to find my X-intercepts, okay, I'm going to make my Y 0. And so I'm going to get 18x to the 4th minus 48x squared. I am going to, honestly, I'm going to divide everything by 6. And so that's going to give me a 3x to the 4th and an 8x squared. So again, I was dividing everything by 6, including the other side with the 0. Now, I'm going to factor this. I'm going to factor out an x squared. I'm going to be left with a 3x squared minus 8. And I'm going to solve. So this one is going to give me x equal 0. This one is going to give me x squared is equal to 8/3. So x is going to equal plus or minus. I'm just going to leave it right now as the square root of 8/3. Okay. We can put that in and get decimals. We can rationalize it. The whole thing is going to be over under the square root. Those are my x-intercepts. To find my y-intercept, I'm going to make my x 0. This is the easier one, because when I make my x 0, any term that had an x is now basically going to be gone. So that is going to be 0. 48, 0 to the 2nd, that's also going to be 0. So I'm going to get y is equal to 0. Now, I will write these ones here in a simplified form. It would be plus or minus 2 root 2, because that's what an 8 is, over root 3. We're going to start having to rationalize these things. Okay, I'm not expecting us to do this right now, but we're going to have to. We're going to multiply top and bottom by root 3 because we don't like radicals. We don't like fractions in a square root. We don't like radicals in our denominator. So my cleaned up answer for this, let me just kind of go this direction, would be a plus or minus 2 root 6 over 3. Those would be the x-intercepts along with x equals 0. My y-intercept is y equals 0. Hopefully this helps you out.